Ciao guys, so welcome to another video of my YouTube channel. So in this video we are going to see how to make the structure which I 3D printed using Bamboo Lab 3D printer, which is like really good. I tried it. This was my first time using this printer. It was my French printer, so I just tried to use it, and like you can see the blade as it is. You can see the printing process time lapse. It's just like at 10 seconds time lapse, but the quality is really good. So we are going to see how to make this structure in Rhino as well as Grasshopper. So you can see in this model, like in this photo, like the curves have been interlocked. Like I mean, the meshes have been interconnected. So we are going to see, like there's a lot of ways to do it. So in that one way we are going to see, like we are going to create a structure in Rhino, and then we are going to extract the curve from the structure, then place the, like create a mesh for the curve. But instead of like creating this mesh, we are going to use a plugin. So like you just need to go to Food for Rhino, and then you need to download this plugin called Chromo Dorish. This is like a plugin which allows you to do ISO surfing. ISO surfing is a major use of this plugin, which I will show it in the process of making this model. Because like if I say like what it does in the word, I think it's very difficult to understand. So I created the curves like because I just recorded this video a lot of times, and like it got fucked up in between due to because of a lot of reasons. So I just keep this curve like this, and now like I'm going to use this curve to create a loft. Okay, so if you don't know how to make this, it's so simple. Like take a circle, create a circle, create a curve. I mean, curve is called circle, and then use Shift plus Alt, which allows you to scale, as well as Shift allows you to scale in the both axes, as well as Alt gives a copy of it, and then you can move it. So like this four circles you can do it easily, but when it comes to this place, like this circle, it's a curve which has been derived from a circle. Okay, so when I use a normal circle here, like when I use the control point to move, you can see it is not like this. You might thinking, what did I do over here so that this curve, when I move, it looks resembles like this. So what I did is, like you can see here the curve. I mean, I used to call all the 2D lines as curves, so don't mistake me. Like you might be thinking, why this guy is calling the circle as a curve. So in this curve, if you see, like I'm just going to use rebuild. So in rebuild, you will get an option of like it rebuilds the curve instead of the fixed point. It creates like a nerve curve. Like it creates the circle into a nerve curve where we can alter the shape with the control points freely. And you see here, like make sub D friendly option, and the model which I'm going to do, you can also do it with sub D, using sub D, but I'm not going to use sub D now. But if you want to know like more about sub Ds, I just posted a lot of videos about this. With the same technique, you can do this model, like 2 videos before I created a facade using a component called bridge. With that component, you can create this model. And I also post a lot of videos about Rhino basics. If you want to learn, you can learn over there. So you can rebuild now, and you get like 8 points. And now when you use the control point, you can see. So there is no pinch. Like we used to call the this kind of sharp things as pinch. like it creates like a pinch, like a sharp, it's not smoother. So I just rebuild the curve to make it like the way I want. So we have the curves, a set of curves. So now I'm going to give a loft over here, like 1, 2, 3, 4, 5, 6. So if you look carefully, the curves loft create path has been created based on the selection which I did. Like I selected this curve first, then second. So it's based on your manual selection. Same in Grasshopper, like it's based on the order of the curve you have been inserting into loft input parameters. Okay. So when I give like it creates a shape. This is really good. But so if you see here, you can see these are called iso curves or like a seam. Okay. So the this like for example, when we use not like when we use loft like this, and instead of using loft, and if we have the if we you can see this is a path or a seam. It shows the seam of every curves which we selected, the direction of the seam. Like instead of using as like a loft component, you can use a polyline and trace out this, and you can use swipe 1 or swipe 2 component to create this. So that is one possibility, first thing. The second thing is, like if you see like the iso curves, like it's going on the way of seam. Okay. So now I if you see in this model, for example, if you see this curve, like if you see the linear pipes, like a pipe kind of structure, it is nothing, none other than that the iso curves, which we are going to extract it from Grasshopper later. But if you see this one doesn't match over here, so I just want this to be like more fluid. What I can do is, like in this case, like like in Grasshopper they used to tell like we get multiple options, or when we create a model, when we adjust something, some parameters, the model will altered. In Rhino also there is an option called record history, which will allow you to do the same process at certain extent, not like fully like Grasshopper. So now I'm going to do loft again. So I can see the loft over here. The surface is greater. Yeah, that's good. Now, like when I use the curve, when I select the curve which I used to create the surface, when I turn it, you can see the surface seam has been turned out. Like the seam has been changed based on the curve, because according to the this surface, the seam is over here. Like you can see a dark line. So the seam, all the seam points are over here. So when I move it, the seam point, I'm just altering the seam point. So all the iso curves have been altered. So I'm going to do this for every other curves. Okay. So you can alter based on your needs. Okay. I'm just trying to tell you about the process began the creation of the model. Like this process, like you just need to understand the process, and you can create your own model, like your own concept. You can also create a better model than what I create, better ideologies. So it's just a step and understanding of each and every process. Okay. So now we got this. In Rhino, usually like what you can do is like you can use line over here, then use polar array. Then select last created. Then move this curve. Then project. So you can see like when I do this, you can see the curve is projected directly to the surface, which is good, but it doesn't follow the ISO curve. Like the curve which we really want is a curve like this one. Sorry. Yeah. So the curve which we really want is this curve to be like created all over the surface, like a contour, but in this axis. So when you use a contour command, it creates a contour. Like if it's a flat surface, it's okay. If you use contour over here also, it creates like a flat. But in this case, like a like a nerve curve, you want a like not a regular curve. So how do we create this kind of curves all over the surface? So in this case, I'll use Grasshopper, which I felt more comfortable. There are processes you can do the same in Rhino as well, but I use Grasshopper. So what like my working style is like I do certain things in Rhino and certain things in Grasshopper. So like there are some things which is easier in Rhino, there are some things which is easier in Grasshopper. Like you just need to blend the working like a workflow. So I'm going to use ISO curve over here. So ISO curve like it generates like it takes a surface and it use the UV point to create the curve. Okay. So like we need to create the UV point between 0 to 1, and we need to make this value to be recognizable with the surface. So for that we are going to reparameterize this surface. Reparameterize is nothing but normalization. So if you have like 0 to 1, the value will be reparameterized to 0 to 100. The value will be reparameterized to 0 to 1. So if here it's 10, then it's here is 0.1. If it's 20, then 0.2. 30. So whatever value it has, it will be converted into 0 to 1 domain. So now we are going to use construct point, and now we are going to use range. So in this range, if you see the domain is 0 to 1. So if I just need to give 10 over here, for example, by default it has 10, but I'm also giving 10. So it creates a value of 0.123. So now I'm just creating the point on y-axis, and when I connect it, you see you don't see nothing. Yeah, but okay. I just like move this like this. So when I click this, like when I select the ISO curve, you can see the curves are being created based on the seam of the surface. Let's hide this. You can see the curves have been created based on the seam of the surface. This ISO curve process, like when you print a non-planar 3D printing, you use ISO curve. Like it creates like a non-planar, like when you want to create a curve on a non-planar, like, or if you want to create a non-planar tool path for a 3D printing, then ISO curve is the best option for that. So now we have here like, but you can increase the value from 10 to my delete. I don't know, in my keyboard my delete option is not working, so I just like I'm not deleting it. So you get like around like 20 curves based on the seam. So what I'm going to do is I'm going to hide this, hide the surface, and I'm going to use this curve to edit it because the record history is still on. Sorry. I'm going to hide this now. So you can see the record history is still on. So I can edit based on the like by this way it's more easier to visualize what is there, what is needed. So now we got this curve. Let's keep it aside, okay? So now I just internalize this and I'm going to hide this. Now the one I created, I just going to delete it. As I said before, delete, because my delete component is, I mean, delete key is not working. I don't know why. So now I'm going to create the loft again. Turn the record history again. Okay. So you can see the seam is over here. So I'm going to use the same process. Like set one surface. Let's hide this for now. So now, for now, I just keep like 5 here to see the curves, like the formation of the curves properly, as well as here 5. So now I'm going to move this. It's so cool. You can move however you want the seam. You can also alter the seam based on your needs. Okay. So now and I'm going to use 20. Let's hide this for now. So now we have like 2 set of curves. So you can see one curve we created is being from here. The other curve is going like, for example, the one curve is like this, other curve is going like this. Like, so other curve is like going like this. So you can technically, you can also create this in entirely in Grasshopper, but I just want to show the interface between both the elements. Like sometimes I feel like I like to edit my model manually in Rhino. So at this time I use Rhino. So it's up to your thought process, okay? I'm just trying to teach you the I'm like the concept behind this. So now I got the curves. Now I am going to do, where is the component? Uh, yeah, here it is. So let's take this. Let's take this, okay? Now I'm going to divide it. So I'm going to divide the curve based on the length of the curve. So let's take the length and let's divide, or else let's say x by 2. So whatever length it has, like that number by 2. So we get, so it looks so more professional, like proportional. Like for example, if the length of the curve is more, then the point is divided, number of point is like the length divided by 2. So now I'm going to use the point over here, and I'm going to use the point over here. So technically what I'll just use bifocal. So I'll just give a random value of 6.5 and 4.5 and 35. So now you see like it looks like a bounding box. Okay. Now I'm going to flatten this. So it's like a single box. Now I'm going to use this voxel data here. I'm going to use 1.5. So you see like a big voxel. Now I'm going to do 0.5 maybe. So 2.5. So here the voxel is being connected. Like now I'll just like increase the point and I'm just like playing down. So technically what it is doing is like with the every points. Just a minute, my laptop is hanged. I just need. I should have explained you first before doing it, but I thought like first like visually. So like yeah. So now I can move my mouse. So you can see like so this sample voxel is like it gives we are using the point and for example like for a example pixel. So if there is like one box, so this create generates a box like the voxel. I just imagine voxel as a box for now. So it generates a box. And this one build ISO surface. So in this case, it just combine all the boxes and it creates a surface. So this is more helpful when you want to model something like this. It takes more time. I'll try to I'll try to get a value where I can achieve the final output. Maybe like I can compute. Just wait a second. It takes some time. I'm so sorry. Yes, I'll edit this part. Okay. So now it's been loaded. So let's lock it. Let's give a value 1.5, 15. I'm just using the value from the old model which I did because I don't want to waste your time. Okay, so like in the recording it takes more time because my laptop is not that great powerful. So like so for example you can create your own simulation, like you can create a curve like random curve and you can voxel this. Like there are a lot other plugin, but I feel this one is a little more interesting and clean with the mesh for especially for 3D printing. The mesh which it provides, it's really good for like it was really suitable for 3D printing. So I like the output. So that's why I'm using this. You can also give a try with this plugin and let me like share if possible share me with your crazy models which you create. So let's try to come. We computate. Okay. Okay. Not bad, but I want some gaps. So what I'm going to do is like let's say like let's my keyboard is not working a lot of times. 3.5. Let's try to compute it. Okay, like to compute it. It's too much. Like maybe 2.5. Compute it. 3. So I computed. Okay, not bad. Okay, so now what I'm going to do is I'm going to like mesh smooth. Like sorry, smooth mesh. I'm going to use this over here, and then I'm going to use Catmull. So Catmull, if you don't find it, it's a plugin, another plugin called Beaverbird. So you just need to, but smooth mesh is like sorry. So if you go into mesh, like you will find it in utilities like smooth mesh. And if you don't know how did I do it, like Control plus Alt, and then press the component, you will know where the component is placed in the above toolbar. So now I just need to connect this mesh over here. Let's hide everything. So technically what I'm doing is like I'm just like enabling solver, because like I'm just pausing the solver, do the changes. So so when I move, it won't be running. Like it will be all, it will be passed. So it will just show like I just manually need to enable the compute. So I change it, I recompute. I change it, I recompute. So in this case, it's so helpful. So now we got not exactly the same, but it's not that bad. So, but at the same time, I just want the curve. Like I just recompute it. So it creates like a bottom. Uh, you can see here, it creates a bottom. Okay. If you want, you can also add this over here. Recompute. So in this case, like so when I'm moving, the components not like processing, so I can move freely. But when you don't do this, sometimes it's the like the mesh rendering or like the process is being like in the background will be running. Sometimes it makes your system smaller, so like slower. So like when I work in a script like which comes the entire of the like it which will be placed in the entire of the screen, I just use this process because after some time like even it's like even it doesn't have that much data trees, or like if you are like cleaning everything also, it has a lot of components, it has a lot of processing. So I always manually recompute it instead of doing this. That's my way of approach. Okay, a lot of people used to do this. If you can also try it and let me know. So now let's try to bake it. Bake. So okay. Let's see. Okay, so this is the model which we created. What do you think about this? I like it, but I don't know about your opinion. This is not the same of what I created, but it looks better for me. Okay, I don't know. Like just tell me in the comment section. It looks better or not. So you can also close the bottom and create like if you don't want to keep it as a pen stand, or like if you want to keep it as a pen stand, then you just create a like a surface over here, and then you can connect it with the mesh. So this is like so after this, what you need to do is you need to select the mesh file, export selected. You need to convert the, I mean, you need to save as STL. It is STL. Yeah. So STL file. So STL file, with this STL file, you just use this STL file, and then you just need to drop this file into a slicer, like a slicer called Cura, or like Simplify, or like there are some slicers in the market. Simplify is little more expensive. For the starter, you can use Cura. So you just need to explore. It's very simple. You'll just learn it after you use like step by step. So that's the way I used to learn. Okay. So that's all for this video. I hope you like this video. Like if you want anything more, like for example, if you want particularly on 3D printing topics or anything special topics, or if you want if you want me to do some certain buildings replication in Grasshopper Rhino, just let me know in the comment section. I'll try to do as much as possible. See you then. Bye bye. See you in the next video. Have a good day.